This is my case study on May 24th, 2024. The severe weather for May 24th got its beginnings as a result of a continuation of a derecho from the previous night as it moved through eastern Iowa into western Illinois. These storms brought 60 to 70 mile per hour winds and 16 total tornadoes in the National Weather Service Quad Cities area, 8 of which were rated EF1, 1 was rated EF0, and 7 were rated EFU due to a lack of damage. There were 3 additional tornado reports for the day. 1 was a landspout in North Dakota along the surface low, 1 was a supercellular tornado down in Texas, and 1 was in coastal North Carolina, produced from some very interesting boundary interactions I'll assess later. The southern area of the severe weather in Texas, Arkansas, Mississippi was characterized by left-moving and right-moving supercells producing mainly hail and damaging wind. The northern eastern areas, Missouri, Illinois, Indiana, South Carolina, and North Carolina, were characterized mainly by multicell clusters from the remnant outflow boundary of the earlier derecho, and in the east, mainly driven by strong mid-level flow. On to the risk overview. This is the 13Z outlook issued by the SPC. There was an enhanced risk over far eastern Iowa and parts of western Illinois for the ongoing derecho, mainly driven by wind, and a 5% tornado risk associated with that as well because of those several tornadoes in the Quad Cities area. The middle slight risk was for clusters of storms along the remnant outflow boundary produced by the derecho, with a 15, 15, and 2% risk for hail, wind, and a tornado. The southern enhanced and slight risks that was off to the east, extending into Mississippi and Alabama, was primarily for significant severe hail, 15% wind risk, and a 2% tornado risk. And the marginal risk that extended east to the Carolinas was a 550 risk for hail, wind, and tornadoes from multicell storms. Here is a quick overview of the surface features. The map on the left is the 12Z surface features. You've got a fairly strong 996 millibar low centered over the southeast corner of North Dakota, with an attendant warm front stretching southeastward through southern Minnesota, southern Wisconsin into the Great Lakes. That cold front stretches south-southwestward through western Iowa, parts of Kansas, Nebraska, Oklahoma, and into Texas, where it transitions over to a dry line. Your derecho ongoing in eastern Iowa at this point is demarcated by those 2 red lines and 2 dots. And then the map on the right is the 0Z surface features. Not much had changed. That cold front that would act as the initiating boundary for storms later on didn't advance eastward too much. The one thing to note, in eastern North Carolina, you've got flow paralleling the coast. That will become important later on. Continuation of the breakdown of surface features. As you can see, that low that was occluding earlier has now shifted off to the northeast, and as a result, all of your surface features, that cold front, that warm front, everything slowed and even stalled the further south you went. In Missouri, southern Illinois, and southern Indiana, you can see the outflow boundary demarcated. That is from that derecho in the morning that impacted eastern Iowa. That was a focusing region for the multicell storms and a supercell boundary interaction that occurred later in the day. And of note, the flow in coastal North Carolina was paralleling the coast still at 0Z, which kept that sea breeze relatively close to shore and caused a very significant boundary interaction that led to that tornado. Now, at the 850 millibar level, the image on the left is from 12Z, the image on the right is from 0Z. So at 12Z, you had a pretty broad closed low centered over the North Dakota-South Dakota border, and associated with that, ahead of the frontal region, you had flow from the southwest and south at around 30 to 35 knots, and further to the east, where that marginal risk was located, you had flow from the southwest and west at 10 to 20 knots. And at 0Z, the image on the right, the low deepens and closed off, heads to Canada. The flow, as a result, weakens slightly, but largely maintains its directional component. And the flow in the marginal region mixes a little bit. It is now southerly and westerly at 5 to 15 knots. Moving on to the 500 millibar level, once again, image on the left is 12Z, image on the right is 0Z. Starting off at 12Z, you've got a negative tilt trough located over the Dakotas, and associated with that, ahead of that frontal region, you've got flow from the southwest and west at 30 to 50 knots, and further off to the east in the Carolinas, where that marginal risk was, you have westerlies and northwesterlies at 30 to 40 knots. Now on to 0Z, that trough has now turned into a closed low as it ejected off into Canada, and as a result, your flow turns a little bit more zonal throughout the day and decreases slightly to 35 to 40 knots, and the flow in the east largely maintains its strength and its direction. At the 300 millibar level, this is where things get really interesting. Once again, image on the left 12Z, image on the right is at 0Z. Starting with 12Z, note the very strong negative tilt trough centered over the Dakotas and Montana region. This is providing lots of lift, lots of forcing for that derecho that was ongoing at this time. Tons of divergence being indicated, very strong difluent flow over Iowa, maintaining that derecho. And further to the south, you still have strong flow and embedded areas of divergence. Particularly notable is in Texas and in northern Mississippi. Farther to the east across that marginal risk, you have fairly zonal flow as well, not as many areas of divergence occurring as a result. Moving on to 0Z, that trough has ejected further off to the northeast, almost into Canada. As a result, your difluence weakens just slightly. Your divergence is still maintained, as noted over Wisconsin, parts of Iowa, Illinois, and Indiana. The divergence was maintained over Texas and northern Mississippi as well, owing to the numerous storms that occurred in those regions. And farther to the east, you have a bit of speed divergence going on as well over the Carolinas, where that marginal risk was located. Onto the instability analysis at 12Z, focusing on mixed layer Cape. In eastern Iowa, you can see a nose of 1,000 plus joules per kilogram of Cape working its way in ahead of that derecho. Farther to the east in Illinois, a large reservoir of convective inhibition would act to kill the derecho off later into the morning. And across the mid-south, 1,000 to 2,000 joules of Cape was noted, very widespread across the entire risk area. Further east into the Carolinas, your capes were less than 500 in most areas, and widespread convective inhibition was present, likely owing to a combination of capping and the remains of the nocturnal temperature inversion. At 20Z, just 1 hour prior to convective initiation over the Mid-South, you have 3,000 to 4,000 joules per kilogram of mixed layer Cape, largely no risk across Illinois, Iowa, and Wisconsin, as the instability in the wake of the morning derecho never really recovered, and a sharp instability gradient can be noted across northern Mississippi. This is due to early morning storms over Tennessee. Storms would later in the day ride this gradient and produce significant severe hail and wind. And in the Carolinas, specifically coastal North Carolina, 2,000 joules per kilogram of Cape was fueling ongoing storms at this time. The 0 to 3 kilometer lapse rates at 20Z were also very notable and very impactful for the day. You have a bullseye of an 8 degree per kilometer lapse rate, essentially over the location of a significant hailstorm in Missouri. Meanwhile, over the Mid-South, 7 to 7.5 degree per kilometer lapse rates were widespread, owing to the widespread nature of these hailstorms that occurred on this day, with one notable area of poor lapse rates in eastern Oklahoma and western Arkansas that was responsible for the weakening trend of any storms that entered that area. Meanwhile, in coastal North Carolina, you have an area of 7 to 7.5 degree per kilometer lapse rates. This is indicative of very strong low-level instability that contributed to the formation of the anomalous tornado. These are the watches issued for the day that were not associated with that morning derecho, starting from left to right. This first one was issued at 3:10 p.m. and focused on the risk for significant severe hail from splitting supercells. In the middle, we have a watch centered on southwest Missouri, issued at 4:25, focusing on similar risks. slightly less risk for significant severe hail from splitting supercells and a multicell line that would form on the cold front. And on the right, at 6:20 p.m., that watch was issued in Mississippi for the threat of significant severe hail and wind because the coverage of supercells had increased greatly at that time. Onto the sounding analysis. This is the 12Z sounding from Morehead City, North Carolina, which is just to the north of Jacksonville, where the tornado event occurred. You had very meager mixed layer CAPE owing to a moisture-rich environment and being so early in the morning. No diurnal heating had taken place quite yet. Of note is that you had some low-level Hodecraft curvature present already with 0 to 1 kilometer storm relative helicity at 107 meters squared per second squared, and even some mid-level curvature with your 0 to 3 storm relative helicity at 75 meters squared per second squared. Mid-level flow was fairly strong and was expected to be the main driver of convection during the day. However, boundary interactions would create a tornadic supercell near the coast. I chose to also grab this 0Z sounding from Morehead City because of its proximity in space and time to that tornadic event which occurred at 2142Z. The mixed layer CAPE was still relatively high at 1,594 joules per kilogram, and your 0 to 3 kilometer CAPE was notable with 102 joules per kilogram of CAPE located that near to the ground. That helped greatly in vorticity stretching to produce that tornado. Your 0 to 1 kilometer storm relative helicity was still high at 120 meters squared per second squared, and your 0 to 3 kilometer storm relative helicity had increased all the way to 188 meters squared per second squared. Your CAPE profile is skinny yet very tall. There's a very low LFC and LCL, and the storm relative helicity values were surely higher around the time of that tornadic event. This is indicative of a locally very favorable tornadic environment generated by those boundary interactions. And here's where I will begin my analysis of the setup for the Verona, North Carolina tornadic event. The storm of interest initiated around 19Z northwest of Warsaw, North Carolina as a multicell cluster. Meanwhile, there was a storm ongoing northeast of Jacksonville, North Carolina that would be a fairly efficient producer of outflow, and said outflow boundary would sag south as that storm died off and eventually stall over the city of Jacksonville. That is where it intersected the sea breeze boundary that was stuck near the coast due to that parallel flow, and your storm of interest would continue its main multicell form for quite a bit of time, but as it got closer towards Jacksonville, it picked up a little bit of mid-level rotation and began to produce severe hail and downburst winds as it entered the localized enhanced shear zone. As the storm of interest progressed towards Jacksonville further, the southern edge of the storm began to push outflow to the east, and that outflow acted as the rear flank downdraft. The earlier stalled boundary that was over Jacksonville became a bit of a pseudo forward flank downdraft, and this created a very tight region of inflow between the two outflow boundaries and the sea breeze front. And over the next 20 minutes, that storm rapidly intensifies its low-level rotation, and your tornado forms by 2023Z. This tornado quickly attained EF1 strength with winds of 90 miles per hour, lasted around 9 minutes, ending within 1 mile of Camp Lejeune, and your storm weakened fairly rapidly as it moved off of shore away from the favorable localized enhanced shear zone, but that environment would maintain itself through the evening as evidenced by the 0Z sounding. May 24th, 2024 serves as an excellent example of how mesoscale boundary interactions can turn a rather benign storm scenario into a significant threat. Overall, the day was a very average May setup for scattered supercells across the Mid-South and multi-cell storms across the Southeast, with boundary interactions making for the most notable storms of the day. Two of the notable areas I did not discuss was Dixon, Missouri, where a left split supercell moved directly into the remnant outflow boundary left by the derecho, causing a rapid increase in updraft intensity and a resultant increase in hail size from quarters and golf balls to baseballs, and supercells that rode The instability gradient created by morning storms in Tennessee over Mississippi that produced significant severe hail and wind.